मेजरमेंट ऑफ रेजिस्टेंस जो मैंने लास्ट क्लास में शुरू किया था, और जहाँ पे मैंने छोड़ा था उस पॉइंट पर थोड़ा सा एडअप करके मैं आपको स्टार्ट कर रहा हूँ। जैसे उस पॉइंट पे मैंने इस डिटेल को सिर्फ इंडिकेट कर दिया था कि वोल्ट मीटर का अपना रेजिस्टेंस है, एमीटर का अपना रेजिस्टेंस है, इंटर रेजिस्टेंस होगा ईएमएफ का, बट यहाँ मैं अभी डिपिक्ट कर रहा हूँ इन द फिगर। इन रियलिटी एन ईएमएफ सोर्स विल हैव अ इंटरनल रेजिस्टेंस। अगर आप कोई सिंपल ईएमएफ सोर्स लेते हैं, सपोज करिए आप कोई सेल परचेस करते हैं, आप बैटरी बोलते हैं नॉर्मल भाषा में, तो उसके अंदर जो है एक इनबिल्ट रेजिस्टेंस भी है। अगर आप कोई लोड नहीं कनेक्ट किए हैं तो आप वोल्ट मीटर लगाएंगे तो 1.5 वोल्ट दिखाएगा, दैट इज ईएमएफ। वाइल इन सर्किट इट विल शो सम ड्रॉपेज बिकॉज ऑफ इंटरनल रेजिस्टेंस। तो अगर आपने सर्किट थ्योरी उतना दूर तक पढ़ लिया है तो आपको पता होगा कि वन थिंग इज ईएमएफ, अदर थिंग इज टर्मिनल वोल्टेज। टर्मिनल वोल्टेज यानी जो टर्मिनल के अक्रॉस मिलेगा while it is in the circuit, यानी while it is connected to a load and the current is flowing through it, so there will be a drop across this internal resistance that is unavoidable. Ideally it should not be there, but in reality there will be some internal resistance and it will consume some voltage, so we will not get exact EMF across your load. That is one thing. Now we are making voltmeter and ammeter using PMMC device. Suppose the most fundamental, I am using voltmeter and ammeter using a PMMC device. So it is an indicating type instrument. Okay, so if you have gone through the construction of this particular instrument, permanent magnet moving coil, so you will see that there is a coil and there is resistors also. Even the coil have some resistance. Okay, if you have gone through galvanometer, if you have opened the galvanometer, again to make a ammeter we will use galvanometer, or we can make a voltmeter from the same galvanometer by adding resistance. Okay, it means this have also its own resistance and this will also have its own resistance. Yani there will be resistance of the voltmeter, there will be resistance of the ammeter. So there are three real conditions. We are interested in the resistance of this unknown resistance, resistor, है ना, resistance of this. So this resistance is unknown and we want to find the Rx. But before finding Rx, before going to write equation, definitely we will use Ohm's law. Okay, and you can use current division or voltage division depending on the circuit. So there will be three kind of reality. One is internal resistance of EMF, other is the resistance of the ammeter, and other is the resistance of voltmeter. Now ideally we don't want these three components. Ideally we don't want EMF with internal resistance. We want the resistance of ammeter negligibly small, and we want ammeter of resistance of voltmeter extremely high in comparison to this, so that it will consume minimum current through it. This is the ideal condition. So I have asked you to write equation for this circuit. Try to write equation. See, the concept is that an unknown resistance Rx whose resistance is to be determined. So by measurement, it is by measurement. So it should be the reading of across the voltmeter and the reading of the ammeter through which the current is flowing. So using this base, this relation as a base, you have to find a final relation in using containing these three in four components. Okay. So write a simple equation using Ohm's law. Try to write an equation using Ohm's law and see what the Rx is coming. What is the expression for Rx? Okay, first you note down this. हाँ, find Rx in terms of known quantity या parameter. तो known क्या क्या है? Known है ammeter reading. देखो हम मेजरमेंट से चल रहे हैं. हमारा उद्देश्य सिर्फ सर्किट सॉल्व करना नहीं है, हमारा उद्देश्य है इंस्ट्रूमेंट के जो रीडिंग हो रहे हैं उसको यूज़ करना रेजिस्टेंस को कैलकुलेट करने के लिए. वी आर नॉट ओनली सॉल्विंग द सर्किट टू फाइंड द आर एक्स, वी आर सॉल्विंग द सर्किट taking into care that instruments reading is also a quantity which will be required, है ना. We will keep this also. So ammeter reading is one known quantity because it will display. My whole sole target is to find Rx. Rx is equal to what? Now I know Rx should be voltmeter reading by ammeter reading. Rx should be a ratio of the voltmeter reading by ammeter reading, because Rx means voltage across Rx by current through Rx. Voltage across Rx by current through Rx. So how I can get the voltage across Rx? Through the voltmeter reading. See, this I am showing separately. Okay, you can think like this also, that this come together. This is a voltmeter. This is a total together. This is a voltmeter. है ना? Means I can show you also like that. This is a voltmeter and this is an internal resistance. In this way. ठीक है ना. So any voltage it is showing across these 2 points, not across itself. This is a pointer. So this is a voltage showing across these 2 points. Voltmeter reading is through these 2 points. Getting my point? You may be thinking that voltmeter is different and then the drop is different. So voltmeter is showing the voltage across these 2 points. Ammeter is showing the current through this wire. Now the same wire is carrying this. Okay. Now what is happening? We have only 2 configuration, either this or this. You have to compromise. You will say, sir, the current is getting divided here. So I will say, okay, 99% will pass through here and 0.1% pass through here. So we will take that into accordance. And we'll assume that whatever current it is displaying, it is going through this resistance only. And here you have to think that whatever voltage the voltmeter is reading is through only this Rx. And this drop is very, very small. Like in 1 lakh and 1 rupee. This is like 1 lakh voltage, suppose 1 lakh, and this is about 1. So this is a ratio. Got it? So let's write, we want this. So what should be the voltage across Rx? That is voltmeter reading. Because it is measurement topic, not completely circuit theory. Now what is the current through Rx? Ammeter reading. है ना? Any doubt? So let's see if I am able to get this or not in this circuit. So what happened when I will write equation for this? You are thinking so many things. Somebody is thinking to write a KVL. See, there is a starting point, but from the very first go, you cannot say that this should be the starting point. First thing is that if I am solving this question first time, maybe I will clear the thing in one shot. Okay, I will just start from the right point. But it may happen that I will not start from there. So don't bother. I have started from this, I have to think from there. No, it is a trial and error. And then somebody will say, okay, this is the thought process. So here the thought process is use the current division. Like this is the current IA. Okay. And this is the IV, current through voltmeter. And if this is IX, current through RX. So for this circuit, using KCL, you can say at point B. Applying KCL at point B, we will get IA, means ammeter reading, is equal to IV, means current through voltmeter plus Ix, current through this. So there are two unknowns, one is IV and other is Ix. This I will know from the ammeter reading. So this is the unknown and this is unknown. There are two unknowns. To eliminate two unknowns, I need three equations or three conditions. If you have to solve two unknowns, you need two conditions. If you have to eliminate two unknowns, you need three equations. So this is the first condition. Now second can be this. This will be V by IV, sorry, V by RV. Voltage across this. The current through this resistance is voltage drop across this point by the resistance. So I eliminated the IV. Now other is Ix. Other is Ix. Okay. So if I say that this is V by Rx, means voltmeter reading by, this is okay? Same voltage drop. Now I have everything known. Ammeter reading, voltmeter reading, voltmeter resistance and unknown. So I can solve. Just solve for Rx. So when you will solve for Rx, what you will get? You will get IA will be like this. Okay. So if I am coming here, so it will be IA by V is equal to 1 by RV plus 1 by Rx. So this implies 1 by Rx is IA, means ammeter reading, by voltmeter reading minus 1 by RV. So Rx will be 1 upon IA point V minus 1 by RV. So that will be equal to V by, because I will multiply both sides by V. So V by IA minus V by like this. So that is voltmeter reading by ammeter reading minus voltmeter reading by RV. Means I am not getting this. I am getting extra term in the denominator. Solving this, if Rx should have come like this, I wanted this, but I got this. So there is extra term. I wanted this, voltmeter reading by ammeter reading, but because of the non-ideality, because the voltmeter itself has a resistance of its own, it is appearing in the mathematical equation. It is like a non-ideality factor. Got it? So suppose RV, means resistance of voltmeter, is very, very high. So much high that you can say it is infinitely high in comparison to other things. Suppose a condition where RV, means voltmeter resistance, is very, very high with respect to this voltage value. Suppose this voltage is 50 volt, assume, and this is mega ohm. So 50 volt by 1 mega ohm or 10 mega ohm will be 0.000000 something. So if RV, ideally if RV tends to infinity, if RV tends to infinity, if I will put RV very, very high, so V by R will be 0. So for that particular condition, Rx will be equal to V by I. Rx will be equal to V by I for Rv tends to infinity or very very high. Infinity means doesn't means कि it is a value which is comparably infinite with respect to other quantities. Suppose I have gave you 1 rupee and I gave him 10 lakh rupees. You will say, sir, this is so high, it is negligible, 1 rupee. Why you are insulting me? Don't give me money, keep your 1 rupee with yourself. And suppose I gave you, okay, boy, see, lease, this is 10 lakh. So we're happy. And I will give him 1,000 crore. So again you will say, keep your 10 lakh. No, you have to think. But you will not like. You will say, this is nothing. 10 lakh is nothing in comparison to 1,000 crore. So you will say, sir, infinite. 1,000 crore by 10 lakh. How much? How much? 10,000 times. 10,000 times I am giving him. If I am giving him 1,000 crore, I am giving him 10,000 times what I am giving you. So, and if I am giving him, suppose I say, okay, take 1,000 crore. Okay, and then I gave him 100 lakh crores. So you will say, again you are cheating. All the time you were raising me, but giving whatever you are giving to him, in that comparison, he is getting infinite amount. Because if suppose I am a billionaire or now become multi-billionaire, 1,000 crore, but now he has 100 lakh crore. So this is the thing. Don't think infinity means any high value. Infinity means if you are putting a value, which will just nullify this effect, it is infinitely high resistance. So it means that ideally for this condition, the ideal condition is the voltmeter resistance should be 0. Resistance should be infinitely high in comparison to other. If the voltmeter resistance is very very high, then whatever reading I am getting of voltmeter and ammeter will show that almost true value of my unknown resistance, because then it will be V by this I, means voltmeter reading by ammeter reading. So here is the, you have noted down? The board is small, otherwise it should be in this line only, so that I can write both equations and you can see the difference. I have to small the font, otherwise I need smart board. Okay. I'm pausing. Again I am showing that by KCL, IA is equal to IV plus IX, and this IV is voltmeter reading by RV, this IX is voltmeter reading by RX. Okay. So IA by V is 1 by RV plus 1 by RX, implies RX is V by I A minus, means voltmeter reading by ammeter reading minus voltmeter reading by voltmeter resistance. Voltmeter resistance. So if RV tends to infinite, so V by RV tends to 0, so Rx will be equal to V by I. ideal condition. Ideal condition, that I am saying. Circuit number 1. Again I am saying. I am just cut short this point. I just jump this step. Okay, you can manipulate and come here. But point is that I tried hard and I got this. I didn't got Rx is equal to voltmeter reading by ammeter reading. I got Rx is equal to voltmeter reading by ammeter reading minus something. And that something is interfering in the true value of Rx. So if that something can be removed, so under what condition? So under the condition if the voltmeter resistance is comparably infinite, means it is infinite in comparison to all other values. We will 1000 crore in comparison to 10 lakh, 10 lakh, 1000 crore in comparison to 10 lakh. So if this resistance is very, very high, so the current will be almost 0, IV will be 0. So this will be showing Ix will be Ia. In that condition, Ix will be I. Na? This is infinite. It means IV is 0. It means Ix is Ia. So I will get Rx is equal to Vx by Ix, and that will voltmeter reading by ammeter reading. So you must know what is the reality and what ideality you are putting that do not exist, but you can make it exist in a certain way. Okay, got it? Now circuit number 2. If somebody start by writing KVL because he sees KVL first, or he is more practicing KVL KCL, so he has got a perspective to write in that way. It doesn't mean he is going wrong. I don't think that I am the perfect person every time I am knowing from where to start. When I was a student, even in today's, if I am not going through books, I can start from anywhere and may get stuck. And that is the reality. You may get stuck and then you will think again, okay, something is choking this process. So what new thing I have to think, what I am missing. So after some trial and hit, you will develop in start from this. You do not require Kirchhoff's voltage law, it requires only Ohm's law. Using Ohm's law, I wrote this. The current is V by R. So even if you are applying KVL, it will come. Okay, so don't think anybody can think the perfect method in first go. It may take 2 times. It may happen in first time. So don't get discouraged. I have thought lengthy. If you are a student, if you are learning first time, I have the full right to start from anywhere and end up in confusion, because at least you discard that method and then you will begin again. Okay, and these are permanent derivation. So we will change the way. Okay, no, start from here. Fine. So again I am taking the circuit number 2. That is very easy. This was also easy. This only require a 1-step change. Everything else is a mathematical manipulation. Now circuit number 2. So if I want to remove the disadvantages that the current was not accurate, exactly the ammeter current was not flowing. So suppose I got biased, let the ammeter current will be the proper. So I will use this, but again I am compromising the voltage reading. So let's see circuit number 2. It is very easy. So I will write, this is E, this is E, same voltage across this and this. So E will be equal to I V R V, or you can say directly voltmeter reading. The voltmeter is put across this circuit, so it is also measuring the same E, but we will not go for E, we will go for voltmeter reading. This is voltmeter reading. that is will be equal to IA RA plus IA, yeah, you can say IX RX, but IX and IA are same because the circuit is in series. Since IA is equal to IX, as ammeter is in series with RX, implies, and this is equal to ammeter reading, I. So RX will be voltmeter reading by ammeter reading minus ammeter resistance. So again the circuit betrayed. Again we feel betrayed. Okay, RX is not coming like this, it is coming this. Again there is a parameter which will affect the reading, and that parameter here is ammeter resistance. So whosoever you will favor, definitely make prove some problem with you. Okay, whomsoever think that will work for you will show some non-ideality. You have to accept that. It doesn't mean he is always wrong or bad. So if I want to go for ideal condition, if I want ki RX should be just voltmeter by ammeter reading, what should be RA? RA should be 0. If RA will be 0, this equation will be equal to this. So for ideal condition, now RA should be 0 means RA is tending to 0. See, 0 means what? 0 means 0.00000000000. Take the circle of Aryabhat 60 times and put a 1. Or I will say I am giving him 0.1 marks. 0.1 marks? Oh, people have got that number here. And somebody got 0.01 marks. So who think more happy? Both will say it is a 0. 0.001 is 0. 0.0001 is also 0. So again I am saying it doesn't mean that RA is perfectly 0, but in comparison to other values, it is 0. If the resistance is mega ohm, this is mega ohm, and sorry, here this is mega ohm, and this is 10 ohm. So thus in 10 lakh you are adding 10 rupees. Whether you will count it or not, oh, I have 10 lakh and 10 rupees. Oh, I am so rich today, I have got 10 rupees extra. No, you will not consider that. No, what rubbish. Got it? So in comparison to, always think engineers, being engineer, infinity doesn't mean think any number. Infinity means that number is existing and that number is very, very much high, so that it can nullify other. It is very, very low, that it do not show its existence. So RA tends to 0. Ideally RA should be 0. That is not possible, but in khayalon mein, in the ideal world, it is possible. So we will see that suppose I am saying RA is 0 and in real RA is 0.001 ohm. So whether it is making much difference or it is not creating difference. Suppose the reading of the resistance should come 10 mega ohm and it came 99.999999 1 mega ohm. So what you will say? In here it is 100. No, that is the thing. Ideality do not exist, but we are going close to ideal condition. So if RA tends to 0, okay, so this Rx will be equal to this by this, keeping RA 0. Got it? So we saw the voltmeter ammeter method, and we also saw the imperfectness in the circuit. That will be, or the non-ideality condition, means the real condition, that this will exist, but it may not affect our reading too much. If our reading should be 10 ohm and it is coming 9.98 ohm, so it is okay. In terms of marks, you will get 10 marks and you will 9.98, so you will think of 0.02. From where you have cut 0.02 marks. I am still not equal to him. Okay, but if you will ask somebody, if there is no ranking position, they both are intelligent. Nobody will say that he is you are 0.02% less intelligent than him. Both are equal. 98% marks and 99% marks, both are good in board exam. In competition exam, 98% marks do not get the job and 99% got the job. So we have to think the practical acceptance of the reading. We have to accept whether this circuit is practically acceptable or not. If it is not, discard it. But if it is acceptable, then keep it in lab at least. Okay, we can measure resistance using voltmeter ammeter method, though it looks bulky, but for our consideration, for our requirement, we can accept this method. That's why it is being taught in the books. Fine. Close this. I will close this. This topic is complete. Few of you people, few among of you, I think, few among of you have understand few part of this lecture. Few among of you have understand few part of this lecture, but all of you can understand all of the lecture if you will go again over it at least 2 to 3 times. Okay, this always happens. Even the brightest student not always catch everything in the class. Okay, even if you are a brilliant person and you are advanced coming, then you will know everything. But most of the time, they have also to go to home and do their homework. Okay, even the most bright student may not be able to learn everything in the class, but if he will jot it down everything, he can then recreate. That is the learning process. Don't think that you have to understand at the same time. This is never going to happen all the time. Few times you will get okay, but most of the time you will be wondering, 5 minutes was okay, then everything lost. Okay, so this will happen. That is the way we human are. But if you will go at home, read it again, write it again, try to understand it again, then it will come. It will again come. It is like a power given to you or shown to you, then you will recall it. If it will come back, if you will go today only. If you will not go today, 85% of the understanding will lost, because your brain is a very intelligent organ. Definitely we are intelligent because of brain. Brain thinks this is required or not required. So if you are not repeating, it will just ignore it. Suppose you came here and I was alone, so I was hearing the sound of fan too much. So my brain and my ear were sensitive enough to hear the sound. But slowly, when I got indulged in lecture, my ear said, no, this sound is of no required. So slowly, though it is coming, it is not affecting me, because my brain discarded this. Okay, similarly, if you are not revising, if you are not going through it, your brain say, oh, this is not required. So it will just got dissolved. That is the importance of revision or to restudy. Okay, I am telling from the experience or knowledge of one of the brilliant student, which I know, that even in the lecture, everybody was thinking that he is understanding. Then he has to go back at home and work a lot. Okay, that is me. You know me, I also know myself. Fine. So this is the closing. I am closing this. I am going to bridge circuit. Fine.